oh my God, it's revolutionizing all of these other industries as well.
Mm-hmm.
It's beginning to change how we see what's possible with computers. And my understanding is that in the early 2000s, you see this and you realize that actually doing that is a little bit difficult, because what that researcher had to do is he had to sort of trick the GPUs into thinking that his problem was a graphics problem.
That's exactly right. No, that's very good. Well,
So
you
create...
did some research.
So you create a way to make that a lot easier.
That's right.
Specifically, it's a platform called CUDA, which lets programmers tell the GPU what to do using programming languages that they already know, like C. And that's a big deal because it gives way more people easier access to all of this computing power. Could you explain what the vision was that led you to create CUDA?
Partly researchers discovering it, partly internal inspiration, and partly solving a problem. And a lot of interesting ideas come out of that soup. Some of it is aspiration and inspiration. Some of it is just desperation. And so in the case of CUDA, it was very much the same way. And probably the first external ideas of using our GPUs for parallel processing emerged out of some interesting work in medical imaging. A couple of researchers at Mass General were using it to do CT reconstruction. They were using our graphics processors for that reason, and it inspired us. Meanwhile, the problem that we're trying to solve inside our company has to do with the fact that when you're trying to create these virtual worlds for video games, you would like it to be beautiful, but also dynamic. Water should flow like water, and explosions should be like explosions. So there's particle physics you want to do, fluid dynamics you want to do, and that is much harder to do if your pipeline is only able to do computer graphics. And so we have a natural reason to want to do it in the market that we were serving. So researchers were also horsing around with using our GPUs for general purpose acceleration. And so there are multiple factors that were coming together in that soup. When the time came, and we decided to do something proper and create a CUDA as a result of that. Fundamentally, the reason why I was certain that CUDA was going to be successful, and we put the whole company behind it, was because fundamentally, our GPU was going to be the highest volume parallel processors built in the world because the market of video games was so large. And so this architecture has a good chance of reaching many people.
It has seemed to me like creating CUDA was this incredibly optimistic, huge if true thing to do, where you were saying, if we create a way for many more people to use much more computing power, they might create incredible things. And then, of course, it came true. They did. In 2012, a group of 3 researchers submits an entry to a famous competition where the goal is to create computer systems that could recognize images and label them with categories. And their entry just crushes the competition. It gets way fewer answers wrong. It was incredible. It blows everyone away. It's called AlexNet, and it's a kind of AI called a neural network. My understanding is one reason it was so good is that they used a huge amount of data to train that system. And they did it on NVIDIA GPUs. All of a sudden, GPUs weren't just a way to make computers faster and more efficient. They're becoming the engines of a whole new way of computing. We're moving from instructing computers with step-by-step directions to training computers to learn by showing them a huge number of examples. This moment in 2012 really kicked off this truly seismic shift that we're all seeing with AI right now.